If you haven't tried this word problem before, maybe take a read, pause the video, and have a go before you look at the solution here. So Kieran is preparing food for his baby and must use cooled boiled water. The equation is always important, describes how boiled water cools, and it clearly then explains like what the variables in the equation are supposed to represent. So T is the time in minutes from when the water boiled. So T, minutes from when water boiled. And maybe you don't need to take note of that, but sometimes I like putting things in my own words. Y is the difference, so that's important. So I might actually just rewrite this. Y is the difference between the water temperature and room temperature. So the difference between water temperature and room temperature is equal to A and K are constants. A times E, well I know what E is, so A is just a constant. I'll hopefully find that out, or they'll probably ask me to. K is a constant, and T is the time from when the water boiled. So sometimes it might take, 3 readings of that question to figure out what everything is, to be sure of the units that we'll be using, to maybe even just to keep in mind, is there a time zero? Is there a start of this experiment, etc.? So let's just read on. The temperature of the water when it boils is 100 degrees. And the room temperature is a constant 23. Write down the value of the temperature difference when the water boils. Well, when the water boils, it's 100 degrees. Y is the difference between the water temperature and the room temperature. So that means in this situation, I'm looking at a difference here. So the 100 minus the 23, Y is 77 degrees. So now what can I do? Y is going to be 77 at the start, like when the water boils. And it says write down the value of the temperature difference, have that. When the water boils. Well, what time is that? And it's time 0. So, I was saying that keep an eye out for time 0, because it's not always very blatantly, obviously written in the question. So the water boils to 100 degrees. That's at the start. That's what happens at the start. And then from then on, it probably cools down. So now I can start filling in stuff. So I have in my formula, the 77 is equal to A times E to the power of K times T is 0. And if I work this out, K times 0 is 0. E to the power of 0 is 1, which means that A is 77. A is 77 degrees. So this here, I'm going to rewrite my formula now. So the difference in the difference between the water temperature and the room temperature is equal to A, E, to the power of K times T. That's my new and improved formula now that I found out what A is. So after the first 5 minutes, so now we're thinking about T is 5. The temperature of the water is 88 degrees. So if I want to use my formula, it's the temperature of the water is 88 degrees, but Y is the difference between the water temperature and the room temperature. So if I'm going to fill in y, it's going to be 88 minus the 23. So y in this situation, when t is 5, because it says after 5 minutes, is 65 degrees. So 65 degrees is equal to 77, or 65, e to the power k times when it's after 5 minutes. So I have a missing power. I'd like to go into logs. But actually, if I look at my log tables, there isn't a number here before the base number. So I need to get rid of that 77 before I do that. So 65, I'm going to divide both sides by 77 is equal to e to the power of 5k. Now I can go into logs. Log in the base e is equal to 5 times k. Throw that into the calculator. And so log in the base e of 65 over 77 is equal to that. That's equal to 5 times k. If I divide by 5, I'll end up with k is equal to minus 0.0338836, etc. And I'm allowed, I'd write down the whole thing, but I'm allowed to give it to 3 significant figures. Well, there's 3 significant figures. Is the one after it big enough to round this up? Yes, it is. So k in this situation, 339. And that's part B. Or part 2. Right. Now we're looking at the fact that Kieran prepares the food for his baby. When the water has cooled to 50 degrees, so the water is now 50 degrees, how long does it take, correct to the nearest minute, for the water to cool to this temperature? Well, if I want my formula, y is the difference between the water temperature and the room temperature, which gives me 27. And I'm going to probably store k in my calculator maybe. So they told me I could round off, so I'm going to store the rounded off version. Sorry, 339. That's the rounded off version. I'm going to store that as a in my calculator. And so I'm just going to write it in here, k times t. Now, so what is the difference in water temperature? Sorry, what is the difference in temperature between the water and room temperature? So we said that was 27 degrees, is equal to 77 e to the power of k times t. So again, I'd like to go into logs, but I need to get rid of this number first. The reason I want to go into logs is I see that I have a missing power. Yeah, k is not missing, but t is. So I have 27 over 77 is equal to e to the power of minus 0.0339 times t. So I go into logs again. The only reason I'm going into logs is because I see I have a missing power. The log of, in the base e, of 27 over 77 is equal to minus 0.0339 times t. Again, just throw that into your calculator. Log of 27 over the 77. That's equal to that. And then I'm going to divide both sides. So I'm going to divide both sides by 0.0339, which I have saved as A in my phone. 30.91, and I'm allowed to go to the nearest minute. So I'm going to go to 31 minutes. Is how long it will take. So that's part 3. Part 4, using your values of A and K, sketch the curve. Well, that's fair enough. I mean, if you don't know how to sketch the curve, maybe you need to actually graph it. I would realistically be throwing in lots of values for t, because if I'm not sure exactly what the sketch of this exponential looks like, then it's important that I give myself the accurate version. So if we just even have a look here, you know, when t is 0, the output is 77. So 0.77, plot it. When t is 10, the output is 55. 10.55, there's your point, plot it, and see what your graph looks like. And then it says, on the same graph, sketch a curve showing the water cooling at a faster rate, and label your graph clearly. So have a go with that. What would it look like? Like maybe you just need to make up a new formula where it cools faster, where it's cooling at a faster rate, and maybe you graph that one. So you just have to figure out what has to change in my formula for the water to show that it's cooling at a faster rate. Now, it's saying that m is going to be a constant, t is going to be time, so perhaps it's the a that needs to change. Well, it says that on the same diagram showing the water cooling at a faster rate, a is the same value from part A, so no, it can't change. So maybe it's the m. So the m, which is the same as the k here, should that be bigger or smaller than minus 0.0339? And you could just check that out. What if you made it bigger? See if it cools faster, then graph that. Or what if you made it smaller? See if you can graph that. And you know, if it cools faster, which way. So for me, it would be just figuring out, right, well, A is the same as the A here, so that can't be the change. E is E. Okay, the K and the M, they're the same thing, but if I change the M, it might change the outcome, because, you know, if time is 0 here, then time is 0 here. So it seems as though the only thing I can change is the M or the K. So K was minus 0.0339. What would you change it to see if the water is cooling any faster? And then sketch that.